Hi guys, thanks for tuning in. This week I'm going to be going over my academic lesson plan with you guys. So let's get started. This one is targeted for an Algebra 2 class. And what I have decided to title this guy is Don't Forget to Drop That Base. And what that's referring to is one of the strategies that I like to teach my students about how to simplify and solve for exponential equations by looking for common bases and then being able to basically ignore them and focus on the exponents. All right, so for my standard states that for exponential models expressed as a logarithm, the solution to ab to the ct power equals d, where a, c, and d are numbers and at the base b is 2, 10, or e. Evaluate the logarithm using technology. All right, so my central focus in this case is that students will simplify and solve simple exponential equations numerically. All right, now I'm going to get into some academic language, the five steps there. So the first one is language function. So that's basically the verbs that I'm wanting to teach the students about and have them use in order to complete these problems. So the first one that I chose to use is solve. That one's pretty straightforward. You see that a lot in math classes, right? So I'm basically going to go through 5 different steps for instructing students how to solve problems. And for you math teachers out there, this may look familiar, so see if you can place this one. So step 1 is that students will begin by examining a problem to make sure that they understand the critical components such as vocabulary, math notation, and what the problem is asking them to solve for. Step 2 is determine a plan to begin solving the problem, breaking it down into clear and manageable steps. Step 3 is begin to complete steps in the solving plan. Step 4 is to determine a solution or solutions. And then step 5 is to check the answer, ensuring that it answers what the problem is looking for and that it makes contextual sense. So if you didn't guess already, that one is actually taken from what we learned about the KWL techniques and the graphic organizer. All right, so my next verb is to simplify. And in this case, I'm going to focus more on how to simplify logarithms. I didn't want to go too much into looking at order of operations and things like that, but more focus on logarithms. So step 1 in this case is that students should analyze problems looking for common bases. Step 2, if the common base exists, I'm going to ask them to continue on to step 3. But however, if bases are not common, but they do have a common factor, we want to use that factor as a new base and then raise it to the necessary power, multiplying the new power with the existing one. So I have an example here, and that's if you have 2 to the x power equals 8, we can rewrite that as 2 to the x equals 2 to the third, because 2 to the third power is equivalent to 8. All right, step 3, ignore common bases and rewrite equations with the exponents as new bases. So my example is 2 to the x equals 2 to the 4. We're looking at this guy, we can tell 2 and 2, so we have common bases, so we can just ignore those bases and rewrite it with our exponents as our new bases. So it's just x to the x equals 4, and we're done. So nice and easy. Last up, solve for the x using algebraic steps to isolate the variable. All right, next up, I'm going to look at my language supports. And so those are basically the tools that we're going to be using to help the students learn this concept. So my pre-language support is partner inquiry exercise, solving simple base 2 equations through inspection method. So what that is students are just going to be looking at really, really simple exponential equations and using what I taught them about the vocab word of simplifying for logarithms to just really easily solve those guys. So once we've gone a little bit more into the concept, partner practice exercises using elimination to solve for exponential equations. So in that case, we're going to have students working together in groups and solving problems, and then sharing their answers up on the whiteboard for them to compare with the rest of the class. All right, let's see here. And post, so the after activity is a group exercise using a practical example to demonstrate understanding of exponential equations and an exit slip. So in this case, we're going to be, I'm going to ask the students a question about loggerhead turtles. So hopefully that's a good little hook in there. And they will be having to figure out how long it takes for turtles to lay enough eggs to reach a certain number. All right, let's see here. That's it for language supports. Going down to vocabulary. So short of our verbs, we also have some important vocabulary words that students will need to know. But in this case, they should already be familiar with this stuff. They've seen them before. But just in case, we have exponential equations, and that is an equation in which a variable occurs in the exponent. For example, 2 to the x equals 8. All right, an exponent now is a power to which a given number or expression is to be raised. So in this case, above x there, that would be my exponent. And then base, this is one that I find actually students get a little more confused about sometimes. So this one probably bears repeating. And that is the number that is going to be raised to the power. So if we look above at this example, 2 in this case would be our base. Okay, moving on to discourse. So this is basically the steps that students are going to take. And so students will work with a partner during the lesson, writing their solutions on a projected handout. Students will discuss patterns. So I'm going to have students going over a series of problems, and each group or pair is going to be solving one or a couple, depending on the size of the class, and they're going to write their answers so that the entire class can see if there's any patterns emerging as they write their answers. And that is actually one of the questions that I'll be asking them, is what are those patterns? Let's see. Number 2, discourse. Students will work in groups of 4 to complete the practical example problem. Students will complete problem on whiteboard and examine the other groups working to produce, Examine other groups' work for procedures and answers. So they're going to get together and discuss a problem involving bacteria working in groups of 4, and then they're actually going to draw what's going on the board. And these answers should be the same or similar, so that's one way for students to check their answers, short of me just coming over there and saying, yes, that's correct. So I think that's a little more dynamic there. Last step, students will complete an exit ticket to demonstrate that they understand the concept in their own words. Hugely important. I think that's one of the most valuable tools that a teacher can use in the day-to-day for seeing if students actually have grasped the key ideas for their lessons. All right. Last up is syntax. So my micro syntax, so some important things that students might need to know would be what an exponential equation actually looks like. And so for this lesson, we're going to be using exponential equations in the form b to the x equals y. All right. And all of the equations that will show up on this homework will be in that form. All right. And then the macro is that we want students to be able to simplify and solve simple exponential equations numerically using practical models such as bacterial growth. And so that's going to be the 4-person activity that they do to get that one. All right, that's pretty much all I have for you guys today. Thanks so much to Connor and Daniel for your good feedback on my original post. You guys gave me a lot of good stuff to work with and work into this guy. So, all right, I'm looking forward to seeing you guys tomorrow.